this video, we're going to be exploring how we can use ChatGPT in algorithms. So let's just go ahead and start with a simple example of prime numbers. So, hey ChatGPT, could you write me a Python script / algorithm to generate all the prime numbers up until a given number x. So hopefully it creates some sort of definition for a function in Python that takes in x as an argument. And sure enough, that's exactly what it does. It labels this as a Python script. It's a function called generate primes, takes in x as an argument, and look at that. It's even documenting the code that it's writing. So this is going to be an algorithm that uses the sieve of Eratosthenes. I don't know if I'm saying that correctly, but Eratosthenes algorithm to generate all prime numbers up until a given number x. So we can kind of test that for correctness in the sense of kind of just running it. Maybe we're not going to be able to like completely fact check it because, as a famous computer scientist once said, like test cases or kind of checking certain inputs and certain outputs can only show the presence of bugs, but does not prove the non-existence of bugs or like the absence of bugs. So I don't know if this is completely robust, but we can try to check it with some numbers and see if it works, right? So this is Python code. Let's actually go over to VS Code, and in my terminal, I actually have I have Python installed on my system. So let's actually go and run Python. So here I'm actually in the Python terminal. Let me actually zoom in a bit. So this is a Python terminal just by running Python on my command line because I have it installed. And I can actually go ahead and type in this code. So if we type that in, paste that in, we're actually going to see that there's an unexpected indent. So let's actually go ahead and create a file for this instead, just to make things easier. So let's call this primes.py. And if I copy that code, this is the function declaration. So like they said down here, there's an example usage of the function to generate all the prime numbers up until 20. So it's definitely going to consist of a function call to generate primes 20, and then it prints the output. And sure enough, that does make a lot of sense, right? These are the prime numbers up until 20. So if we actually go ahead and run that, if I quit my terminal and then run that file using py.primes, we can see that that's actually the output, right? We can try it for a larger number. Let's go crazy and put 1,000,000, and hopefully that doesn't take too long. But yeah, that's a lot of output right there. I guess my computer is pretty fast at that, as computers are. So yeah, that's a lot of numbers. I don't know off the top of my head if these are the prime numbers, but I think this algorithm is pretty true and tested. And that's one thing that ChatGPT is going to be good at, right? Is if you ask it for a well-established algorithm, that's going to be something that's very well documented and proven, and that's going to be code that's already out there. So this is stuff that it's probably not going to be getting wrong because there is a good, robust explanation for how this stuff works. And there's actually other algorithms used for generating primes. So it's interesting that ChatGPT happened to give me one that was quite well known and efficient. Could you use an algorithm other than the sieve of Eratosthenes? If I can spell that correctly. Hopefully I did. And certainly, here's an implementation of the trial division algorithm to generate all prime numbers up until a given number x in Python. So this is going to be a completely different function definition, but it's probably going to give us the same output in terms of generating all the primes up until a given number. But yeah, let's go ahead and give that a try too while we're at it. So up here we've got the definition for the sieve of Eratosthenes. Let's prefix this function called as sieve so that we don't call it. So here we're going to be calling our new generate primes function. And if we call it the 20, it should give us the same output, 2, 3, 5, 7, 11, 13, 17, 19. So if I go ahead and run that, sure enough, yep, that's exactly what it's giving us. So an interesting thing about algorithms, if you're not familiar with computer science and the study of sort of writing code and these algorithms in the first place, is that they have ways to be measured. So those two things are space and time complexity. So let's actually ask, so this is actually a footnote here that they include. Note that the trial division algorithm is less efficient than the sieve for generating prime numbers, especially for large values of x. So let's actually go ahead and try that out, right? Because like earlier we went ahead and ran a million on the sieve version of this function. So let's try to run that with generate primes. And oh, you can see that that's taking a little longer to come out, right? So it's giving us the same answer, surely. However, you can see that my computer did actually stall up for like a second or two. So let's actually ask GPT why that is. And the way you would phrase that is, well, you could probably ask, why is one slower? So that would be a sort of naive question. But if you're familiar with the theory behind algorithms, you could ask it, what are the time complexities of both of these algorithms? So let's see if it can tell us that. Time complexity of the sieve of Eratosthenes algorithm to generate all of the prime numbers up to a given number x is big O of x times log to the log of x in the worst case scenario. So if you don't understand what this means, the big O notation is a way of describing the runtime complexity of algorithms. And there's a lot of sort of understanding that needs to be done there. But we see here that the trial division algorithm has a complexity of O of x to the power of 1.5 in the worst case. And that's considerably worse, right? So if you think about the graphs of both of these, right? So if you kind of view a graph with having function as a function of the size of your input and the number of time that it takes for the algorithm to complete, this one is going to grow substantially slower than this one, right? So this one's going to blow up. So as your x increases, the amount of time that it takes for the algorithm to complete is going to sort of skyrocket because it's like exponential, right? It's to the power of something. So yeah, we can see like why that is. Like, why did one take longer than the other? If you want to know more about this, we can probably continue the conversation with ChatGPT and just continue asking questions, right? Like, this stuff is going to work super well if you're like curious about learning and just know what to ask.